So this is the fluctuation of energy. The name itself specifies fluctuation of energy. So the variations of energy above and below the mean resisting torque. Sorry, okay. Mean resisting torque mean resisting torque line are called for fluctuation of energy. The difference between the maximum and the minimum energies is known as maximum fluctuation of energy. The maximum fluctuation of energy E is equal to maximum energy minus minimum energy. So these are the solutions we can get it here. Then coefficient of fluctuation of energy. So it may be defined as the ratio of maximum fluctuation of energy to the work done per cycle. Also a group so the coefficient of fluctuation of energy, we can say the ratio of maximum fluctuation of energy to the work done per cycle. So we can denote it as a C suffix C. C specifies coefficient, E specifies energy, fluctuation of energy. So the C specifies the coefficient. So I have specified the fluctuation of energy. That's equal to maximum fluctuation of energy divided by work done by cycle. So work done per cycle. The work done per cycle may be obtained by using following two reasons. Work done per cycle. So T mean into theta. So T mean is equal to mean torque. So theta is equal to angle turned in radians in one revolution. Then so theta is the angle turned in one revolution. So 2 pi in case of steam engine and two-stroke internal combustion engine. So 4 pi in case of four-stroke internal combustion engine. These are the formulas we are using here. So T mean, that is mean torque, is equal to P into 60 divided by 2 pi n is equal to P by omega. So P is the pressure. Sometimes we can use P as an force one. So omega is the angular velocity. So due to the movement of particle in a circular path, that is called angular velocity, angular displacement, whatever may be. It moves in a circular path. So P power transmitted in watts. So N is speed. So these are the values shared in WhatsApp group as an mentioned one. So work done per cycle. So the work done per cycle may also obtained by using following relations. So work done per cycle is equal to P into 60 divided by N. So number of working strokes per minute. So N in case of steam engine and two-stroke internal combustion engines, and so N by 2 in case of four-stroke internal combustion engine. So N by 2 especially for four-stroke engines. So N is for two-stroke engines. So these are the main things here. Then flywheel. So flywheel used in machines serve as a reservoir. It's a storage one, which stores energy during the period when the supply of energy more than the requirement, and releases it during the so flywheel purpose is serve as a reservoir, stores energy during period when the supply of energy is more. So whenever it get maximum energy beyond that source requirement, so it have excess of energy means it will be transferred to the specific areas, or those who want special cases at all means we can share the things here. Supply of energy is more than the requirement and releases during the period when the requirement energy is more than the supply. So the coefficient of fluctuation of speed, the difference between maximum and minimum speeds during a cycle is called maximum fluctuation of speed. The ratio of the maximum fluctuation of speed to the mean speed, that is C suffix S is equal to so the difference between the maximum and minimum speeds during cycle is called maximum fluctuation of speed. The ratio of the maximum fluctuation of speed to the mean speed is called coefficient of fluctuation of speed. So energy stored in a flywheel. So the energy stored E is equal to mk square omega square Cs is equal to mv square Cs. So m is the mass of the flywheel. So k, radius of gyration of the flywheel in meters. So omega is the angular speed in radian per second square. The coefficient of fluctuation of speed C suffix S. Then V, mean linear velocity. Then dimension of the flywheel. So the tensile or hoop stress considered. The density of rim material considered. Then speed of the flywheels in RPM. Then angular velocity of the flywheel in radian per second. So V, linear velocity at the mean radius in meter per second. So omega r is equal to dn by 60. So dimension of the flywheel rim. So mass of the rim m is equal to volume into density, that is equal to rho. So dA, if the cross section of the rim is rectangular, then so A is equal to B into T. So B is equal to width of the rim and T is thickness of the rim here. So flywheel in punching presses. So the following of a flywheel in an engine is to reduce the fluctuation of speed when the load on the crankshaft is constant and the input torque varies during the cycle. The flywheel can also be used to perform the same function when the torque is constant and the load varies during the cycle. Such an application is found in punching press or in riveting machines. So these are the things we are used. Then dynamics of cam follower mechanism. The cam mechanism we know very well. So it's periodic motions. We prefer only cam analysis, cam mechanism. Cam dynamics is the study of cam follower system with considering the dynamic forces and torques developed in it. That's why we are using these things. Types of cam systems: rigid body cam system, elastic body cam systems. So these are the things we are utilizing here.